Question number 1 says, write in exponential form. It says log base 5 of 1 over 25 equals -2. And if we recall the way we change from logarithmic form to exponential form, we take the subscript. This is log base 5. The subscript is what we call the base. The exponent is always the number on the other side of the equal sign, because log means exponent. So log equals -2 means exponent equals -2. So my exponent is -2, and that equals 1 over 25, which of course is a correct statement, because when you do 5 to the -2, you're doing 1 over the negative exponent, means you're doing the reciprocal, and 5 to the 2 is 25, so it becomes 1 over 25. Remember that the number, the final answer that you're going to get, the number that is you're taking the log of, this is log base 5 of 1 over 25, always has to be a positive number, because whenever you put, your base is always going to be a positive number. And whenever you take a positive base and put it to any exponent, whether it's positive or negative or 0, your final answer will always have to be positive. We say that the domain of the log is only positive numbers. When we do log of something, the number that you're doing the log of, that is sometimes called taking the log of, is always has to be a positive number. If I put a negative number over here, it will, you'll even try it on your calculator, you'll see it can't be done, because you'll get an error message, because this number always has to be a positive number. Okay, so this was the answer to the first question. Okay, now we have the second question. It says solve or figure out the value of log base 4 of 1 over 64. So we want to figure out what log base 4 of the number 1 over 64 is. We don't know what it is, so let's call it x. It's always easier to understand questions, log questions, if you switch them from the log format to the exponential format. So we now have this in log format. Let's put it in exponential format. So again, like we did before, the base is 4. The exponent is the number that's on the other side of the equal sign, which in this case is an x, equals 1 over 64. Now this was a multiple choice question, and we could look at all the answers and pick out the correct answer. The first thing I notice is that when I do 4 to the x, I'm getting 1 over 64. In other words, I'm taking a reciprocal. Now, when I'm doing exponents, the way I do reciprocal is if my exponent is negative. So right away, I can eliminate choice A and B, because those are positive numbers. They're not going to give me a reciprocal. I know it's a reciprocal when I see 1 over a number. So it either has to be -1/3 or -3. Well, let's go a step further. 1 over 64. Well, the 64 is really 4 to the 3rd power. So therefore, my answer, the exponent is going to have to be a 3, but it has to be a negative because we're doing the reciprocal. So the final answer has to be choice D, -3. Did anybody get those answers? Anybody want to raise their hand or say that, or put it in the chat, or just answer? Okay. So let's now look at the last question. What does the last question say? I'm going to erase these two because I'm going to need the space for that. It's asking us to expand a expression that has logs in it using what we call logarithmetic. Let's put the three basic rules that we use in logarithmetic on the board and then see how it applies to this problem. I'm just going to write, I'm not going to write a base, even though I really should be, but remember, if I don't write a base next to the word log, it's not that I forgot the base. It's understood to be what we call a common logarithm, where the base is 10. That happens to have a base of 14, but the rules apply whether the base is 10 or 14, as long as my base is a positive number. It could be a fraction, it could be anything. The first rule we talked about was that when we multiply numbers, what we do to their logs is we add them. And the reason for that is because logs are exponents. We keep saying the log is the exponent. And we know when we're multiplying numbers that are written with an exponential form, in other words, a base with an exponent, what we do to the exponents is we add them. The logs are the exponents, so we add them. That was rule number one. Rule number two, or property number two, was that when we divide numbers, we subtract their exponents. And rule number three was that when we have a log that has, with a number that has some exponent, what's going to happen is the exponent is going to become the coefficient. In other words, this is going to be n log a. And those were basically, let's just leave them over here. These are three basic rules of logarithmetic. Again, when we're doing these problems, we usually start from the condensed side and expand it. We may open it up. But we could have just as well started from the expanded side. In other words, if I see something like log A plus log B, I know that I can contract it back to the log of A times B. These two things go both ways. When you're multiplying numbers, you add the logs. Vice versa, when you're adding the logs, it means that you were originally multiplying the numbers. Similarly, if you see two logs subtracted, it means that you must have originally been dividing, etc. Okay, with that in mind, let's look at this problem that we were given. The first thing I see in that problem is that I have something that's written in radical form. I have the 9th root of 17. And you may recall that one of the things I said was that when you have radicals, you don't want to work with radicals in terms of this exponential chapter or in terms of the logarithmic chapter. So whenever you see logs, first write it in exponential, as an exponent rather than a radical. And this means that it's 17. Remember, the index here is 9. It's telling me that I'm doing the 9th root of 17, which means in terms of the exponent, it's 1 over 9. A fractional exponent tells you to do a radical. If I see 17 to the 1/9 prop, it means It's the radical with index 9. If I would have seen something like 25 to the 1/2 problem, if I would have given you something like this, 25 to the 1/2 exponent, that would have mean that you're dealing a radical. The index is 2. Now remember, when the index is 2, that's just a regular square root. We usually don't put in that 2. This just means the square root of 25. So that's the first thing we notice, that we have, this is really log base 14 of 17 to the 1/9 power, because I changed that radical to a exponent, s squared over over s squared r. So that's number one. Anytime you see a radical, change it to a fraction exponent. And now I'm going to use these rules. And the first rules I always look for are rules 1 and 2. Is there any multiplication? Then I'm going to change it to addition of logs. If there is multiple division, I'm going to change it to subtraction of logs. And I see basically what I'm doing is dividing the 17 to the 1/9 by s squared r. So in terms of the logs, I'm going to be doing the log of base 14, these are all base 14 logs, of 17 to the 1/9 minus the log base 14 of s squared, and also minus the log base 14 of r. Even though I'm multiplying these two together, I'm not, when I pick these signs, I pick it based on what it's doing to the whole problem. And the 17, anything that's in the numerator stays positive, but anything that's in the denominator has to be subtracted. This r is really being a divisor of the 17 to the 1/9. That's why I make this sign a minus, not a plus. The last step that I do after that is I look for my exponents, and there are two places where I'm seeing exponents. I see an exponent of 1/9 over here and an exponent of 2 over here. Those exponents become the coefficients. That's my step after I've done the addition and subtraction. I've taken care of steps 1 and 2. Now I'm on property number 3. So this will give me 1/9 log base 14 of 17 minus 2 log 14 base 14 of s minus log base 14 of r. And that's, now I have it all expanded in terms of individual logs. And I look at the choice and be very careful, because C and D are very similar. It has to be choice C, because you have to subtract both the 2 log s and the log r, because they're both were in the denominator. So that is choice question number 3. All right, so we're going to continue with this. We will be finishing up this chapter today. And we're almost finished. There's just one more topic that we want to take into consideration. Okay, I'm going to erase this, but I'm going to leave these rules on the board because we are going to be using those rules. So here's the thing. Let's just remember we are 1 week away from our final exam. Our final exam, I'm just putting this because before I forget to remind you about this. The final exam is going to be on December 11th. That's a week from tomorrow. It's next Friday. Today is the 3rd, tomorrow is the 4th. A week from the 4th is the 11th. That's when our final is going to be. For this class, it's from 12 to 2 p.m. If you have any kind of conflict, anything that does not allow you to take it at that point, you have to let me know so we can make alternate arrangements. You will see I put all this information on Blackboard. On top of that, I sent it out in an email. So you should know this already. Be prepared to start exactly at 12. Don't come in 15 minutes late. I'll set up the Blackboard so it opens up a little bit earlier and it closes a little bit later, just to give us a little leeway. But basically, you have to be ready to take this test between 12 and 2 p.m. on Friday. Just like we did with the midterm, it's going to be on Blackboard. There's a practice final on. Will we be getting on a Zoom call for the final? No, you're going to have to, because I don't see how you can be on Zoom and taking the final exam is on Blackboard. So I don't think it's possible. I mean, some people, if you have two devices, you could have one device on Zoom and one device on the Blackboard, or you could split your screen. But once you start splitting the screen, then you're running into difficulties with the size of the device, and some of us don't. So I am not requiring you to do this on Zoom. I know that probably it is more secure if I'm watching you on Zoom, but I think it's better if you can just sit and do it, sit at your computer and concentrate on your Blackboard exam. This is exactly what we did for the midterm. Unless I get different instructions, and I haven't as of now, this is the way we're going to do it. You're going to go to your Blackboard account and you're going to do your exam on Blackboard. Don't forget, yes, you can definitely use a calculator. As a matter of fact, you have to use a calculator because a lot of the questions can't be done without a calculator. The calculators should not be the graphing calculators. The calculator should be a regular scientific calculator, the way I explained it at the beginning of the term. That's number one. Number two, when you open your exam, you have to complete the exam in one sitting. It's going to be timed. There are going to be a total of 30 questions on the exam. You will be given 2 hours. And at the end of 2 hours, if you haven't submitted your exam by then, it will close down and submit automatically on its own. So make sure you're keeping aware of the time. And yes, is there going to be time to review the test? I hope some of you have seen that I already put a practice final on. Now the practice final happens to have 40 questions, even though your final is only going to be 30. It's just that to make sure you have enough practice, they made it 40 questions, but the final itself is going to be exactly 30 questions. I let me just go through the steps that I wanted to say. All your marks and all your work really has to be completed by this weekend. All the homeworks, all the tests on Delta Math, the tests that were given on Blackboard have to be completed by December 5th. That's this Saturday at 8 p.m. That's the time I gave it as. The only thing that extends beyond that is the practice final. Now, the practice final is just for you. It's a practice final. It's not a test. Even though I made the practice midterm a test, the practice final is not a test for you. It's just a practice. So you see what the final is going to be like. So you get an idea. You should be a little bit familiar with the method already because we've done several tests that way. Your final grade is made up of several parts. 10% of your final grade is the homework. The homework that you did on Delta Math. Now I'm going to check on your homeworks on Delta Math, and I think there at this point there are 17. If you've done at least 15, I will give you the full 10%. In other words, I give you a little leeway to have left out one or two homeworks. But there are 17 homeworks. Again, that has to be completed by December 5th. In addition, on a Delta Math, there were 3 tests. Those also have to be completed by December 5th. The 3 tests on Delta Math, plus there were on Blackboard another 2 tests. There was the practice midterm, and there was the test on conics and trigonometry. That's the other 2 tests. So there have been a total of 5 tests aside from the midterm this term. Those 5 tests consist of 20% of your grade. The midterm consists of another 10% of your grade. And the final exam consists of 60% of your grade. So you by this weekend, you should have completed 40% of your grade. Now, what I will do with the practice final is if you take the practice final and you do very well on it, and you didn't do so well on one of the tests, I'll exchange the mark. Let's say you got a mark, not on the midterm, but on the practice midterm, you got a 70, and on the practice final, you get a 90. I'll take the 90 as your practice midterm, so it'll up your average. So I'm not using it as a test grade, but I will use it to improve your score if it indeed does. If it doesn't improve your score, it's practice. Obviously, the point of it is to get it done. Now, I suggest you have it all done by Tuesday, because on Tuesday, we are completing our classwork today. So by Tuesday, we will review any topics that you want. So either send me an email as to which topic you would like me to do, or which question you would like me to do, or put it on the chat, or actually say it in class. That's how we're going to review. I am going to review the marks that you do on the, you don't know what my email is? I'm sending you emails all the time. Just here's my email address, P. Weinberger. At Mac. I hope you see my emails. I must send you at least 3 or 4 a week. Look out for them. Don't forget, if you have any questions, you can ask them at any time. Make sure you're ready for and prepared for the final exam. Again, I will try and review and see what examples people are making mistakes on. Today, we're going to be basically the type of questions we're doing are going to be questions that you might have seen on the final that apply to the topic of um, of exponential equations and log. Okay, having said that, I think it's time for me to get started doing some teaching. Let's say I wanted to solve an equation. There are two types of equations that we might come across when we're in this topic of exponential and logarithmic equations. One is logarithmic equations and one is exponential equations. And we actually talked about solving exponential equations last time on Tuesday. I'm first going to go over how to solve logarithmic equations, and then I'll review how to solve exponential equations. So let's say I gave you an equation that looks like this. Log 5x equals 2. This is an example of a log equation. It happens to be in this equation, I didn't write in the index. I'm sorry, I didn't write in the base. I'm just writing the word log. Remember, when I write just plain log, it means that my base is understood to be 10. There's an invisible 10 sitting here, and it's what we call a common log. And also, in most cases, in order to solve logarithmic equations, all we have to do is switch from the logarithmic form to the exponential form. Now, if I want to switch this from logarithmic form to exponential form, I take my base. Again, if no base is written in, you know the base is 10. So that's 10. Put it to the exponent, the number on the other side of the word log. The thing that the log is equal to. Remember, the word log is equivalent to the word exponent. The exponent equals 2. So my exponent is 2. So that's 10 squared. That always equals the number that's next to the word log. So here's my exact same example written from log format to exponential format. Usually, once it's put in exponential format, it's possible to solve. Now notice 10 squared is 100, that we know. So we got 100 equals 5x. And divide 100 by 5 and you get x equal to 20. Notice we have to make sure 5 times 20 is 100. It's a positive number. The number next to the word log can never be negative. It always has to be a positive number. So that's one type of log question. Let's look at this example now. I'm giving you an example that says log base 2 of x plus 7 plus log base 2 of x minus 7 equals 3. Sorry, had to fit in that 3 there. How do we solve this type of an example? It again is an equation where I have a log on one side and a number on the other side. Except in this particular example, I have more than one log on the side. I have 2 logs on the left side of this equation. And when I gave you a method of solving a log equations by saying, change it from the log format to the exponential format, I could only do it if I had one log on the right side, or on the left side, and a number on the other side. I can't have multiple logs. So somehow this is a problem because I have more than one log here. But I remember that any of these rules that I talked about, for example, log AB equals log A plus log B, any of those rules go both ways. If I have 2 logs being added, I know that originally what must have been happening is that these 2 numbers must have been multiplied. Remember, the logs are the exponents. If the exponents are being added, then the original numbers were being multiplied. So instead of, before we were expanding, now we want to contract our log expression to a single log. So this is what I do. I do the log base 2, and I don't add these 2, I multiply them, because I know when I'm adding the logs, I'm multiplying the numbers. Now, the advantage of doing this is now that I'm left, I've contracted this to a single log. So now I have a log on one side, a number on the other side. I can now go to my exponential form where my base is 2. My exponent is a number on the other side of the equal sign, that's 3. My base 2, my exponent 3, and that's equal to the x plus 7 times the x minus 7. And what I've done is I've converted this log equation into a regular algebraic equation. Let's see if we can solve this. Well, obviously I can do 2 to the third. 2 to the third is 2 times 2 times 2, that's 8. And this is x plus 7 times x minus 7. So that is, these are conjugate binomials. I don't even have to do a whole FOIL. I can just do first and last because these are conjugates. That'll give me x squared minus 49. And I can even go further. I now can get the 49 to the other side. Which will give me 57 equals x squared. And this is a regular quadratic equation where I can use the, what we call the square root rule. Remember what we do plus or minus the square root of this number. So I get 2 answers. I get positive the square root of 7 and negative the square root of 7. But remember what I told you when I talked about logs at the very beginning. The number that we're taking the log of has to be a positive number. So I cannot use the negative answer. So instead of doing negative, I just take the positive answer. So the answer comes out to be the square root of 57. In other words, I take my log. If I have more than one log, I condense it back to a single log. If this is a plus, that means these 2 things are multiplied. If this is a minus, it means that I'm dividing. And then I just change it from the log format to the exponential format so that I end up with a regular equation to solve. Don't forget, after you get your answers, just check that the answer you got is not making the number that's standing next to the log negative or 0. Because if not, you have to get rid of it. You have to exclude it. And if there, sometimes, in this case, we had 2 answers, we excluded 1. We only kept 1 answer. Sometimes there's 1 answer and it's no good. Sometimes there's 1 answer and it is good. Sometimes there are 2 answers and they're both no good. In that case, there's no solution. But you must not accept as an answer any answer that will make the log, the number that you're taking the log of, a negative number. Okay, let's see if we can do, I'm going to do another problem together. We're going to do it together. And after that, I'm going to give you one to try on your own. So let's say I have this question. Okay. Again, I have a log equation. I want to solve for x, and I have more than 1 log on my left side. And I see that the sign between the 2 logs is plus, so I want to contract this back to a single log. And the way I'm going to do that is I'm going to multiply, because when I'm adding logs, it must have been I originally was multiplying the numbers. So this becomes log base 3 of the x times the x minus 24 equals 4. We rewrite this where there's a plus between the logs. I multiply the expressions and make it into a single log. Which means now that I have a single log equaling a number, I can switch it from the log format to the exponential. My base is 3. My exponent is a number on the other side of the equal sign, so that's 4. That equals the x times the x minus 24. And now we have a regular equation that we have to solve. First of all, I have to figure out what 3 to the 4th power is. So that's 3 times 3 times 3 times 3. That comes out to be 81. And this becomes x squared minus 24x. And it turns out that what we're dealing with here is a quadratic equation. And we want to solve this quadratic equation. And we know when we want to solve quadratic equations, we want to get them equal to 0. So I'm going to subtract 81 from both sides. And this will give me 0, because it's easier just to go this way than to go bring everything to this side. Is going to give me x squared minus 24x minus 81. And now I want to factor this. So here are my two parentheses. Hopefully I can factor it. It's going to be x and x. And one side, since my final number is negative, one's going to be positive and one's going to be negative. And we need two numbers that when we multiply them, they gave me 81. But when I subtract them, they give me 24. And I think if you take 81 and you divide it by 3, you get 27. So obviously one number is going to be 27 because 27 minus 3 is 24. And the larger number, the 27, is going to be the negative, and the 3 is going to be the positive. This is a regular quadratic equation that we have to solve. Now we set each of the factors equal to 0. So we get x plus 3 equal to 0, and x minus 27 equal to 0. This, when I subtract 3, gives me x equals negative 3. And here I'm going to add 27. So that'll give me x equal 27. I got two answers to my equation, negative 3 and positive 27. But remember, I have to be very careful because I cannot take the log of a negative number. If x is negative, this will be negative 3. I certainly can't use this I have to discard. It's what we call an extraneous root. We've had extraneous roots before in this class. Remember when we did equations with fractions, and if the denominator of the fraction turned out to be equal to 0, we couldn't accept that answer. Here's another case, or if we had the square root of a, and it came out to be a negative number in a radical equation, we couldn't accept that answer. So this is the third place we're seeing something called an extraneous root, a root that we did all the work correctly, but this does not work because you can only use logs when the numbers that you're taking the log of, the number that's right next to the word log, has to be positive. This negative 3 disqualifies. The only thing that works is the 27. So my solution to this equation is x equals 27. Notice I discarded one and I kept the other. Okay, I think it's time for you to try one on your own. Let me see if I can find one. And while you're working this out, I'm going to take attendance. Okay, so here's the question that I'd like you to solve. Log x plus log x plus 15 equals 2. See if you can solve that equation. Okay, let's go over this problem now. It says log x plus log x plus 15 equals 2. Now, obviously, we have the same situation where we have more than one log at a time, and we have to combine them, contract them back to a single log. And I see the sign between the two log expressions is plus. That means, again, I'm going to be multiplying. So this is log of the x times the x plus 15 equals 2. So now we have a single log equaling a number. We can go from the log format to the exponential format. The exponential format we'll get by taking our base, and since no base is written in, this must be a common log. It must be my base is 10. My exponent is a number on the other side, so that's the 2. That's going to be equal to the x times the x plus 15. And 10 to the 2 is obviously 100 equals x squared plus 15x when I remove the parentheses. And again, it's a quadratic equation, so I'm going to bring the 100 to the other side because that's the easier way to go. So that we end up with, over here equaling 0, x squared plus 15x minus 100. And again, since it's a quadratic equation, so we're going to try and factor it. They usually give you relatively easy factoring on these quadratic equations that are part of this log example. This is going to be x and x. Since the last term is negative, one is positive, one is negative. And we need two numbers that multiply to 100, but when you subtract them, you're going to get 15. Obviously, that's 20 and 5. And it's the 20 that's going to be, I'm sorry, do this. The 20 is going to have to be the positive one because this is a plus 15, and the 5 is going to be the negative one. The larger number has to be the positive one. So therefore, I'll get x plus 20 equals 0. So this gives me x equals negative 20. And x minus 5 equals 0. So that gives me x equal to 5. And I go back to my original equation, and I see I can't, I'm doing the log of x, so I certainly can't do the log of negative 20. I've got to discard this answer, but the 5 certainly works because log of 5, that's a positive number. I just have to check and make sure that I'm not taking the log of a negative number. So my final answer is not negative 15, not negative 20 and 5, it's just 5. Don't forget to discard a answer that gives you a log of a negative number or a log of 0, because that is not in the domain of the log. You cannot do the log of a negative number. Let's do one more similar to this. What if I gave you this example? log base 3 of x plus 2 minus log base 3 of x equals 1. This is again a similar type question, except instead of having the two logs being added, now we have the logs being subtracted. And if the logs are being subtracted, that must mean that the operation is not multiplication, but the operation is division. In other words, when I go to contract these into a single log, this will give me log base 3 of x plus 2 divided by x. Since there's a minus here, it's a division, and that's equal to 1. But again, once I have it contracted to a single log, I can then go and change it to the exponential form. In this case, they did give me a base. The base is 3. The exponent, again, is the number on the other side, which in this case is 1. That equals x plus 2 over x. Of course, 3 to the 1 is just 3. So this is 3. I'm going to put the 3 over 1 so I have, since this side is a fraction, this side should be a fraction as well. And I get a regular proportion that I just cross multiply. 3 times x gives me 3x. 1 times x plus 2 gives me x plus 2. And it's just a regular equation now. It's just a regular algebraic equation. I get 2x equals 2. And finally, that gives me my x equal to 1. Notice 1 is an acceptable answer because it's not making anything negative. So my answer here, there's one answer. Sometimes you get two good answers. It's possible to have two answers. It's possible to have one answer. It's possible to have no answers, depending on the type of equation. But this is how we solve log equations. Okay, so now I just want to go back and review. We did this on Tuesday, solving of exponential equations. This was a logarithmic equation. Basically, the way we solve logarithmic equations is we go from the logarithmic form to the exponential form. Again, if we have more than one log, we have to condense it. So we only have a single log before we switch it to the exponential format. Okay, I'm going to erase this one now. And let's take an example that looks like this. 5 to the 10 minus 2x equals 125. It's called an exponential equation because the variable is in the exponent. We know the base, we just don't know the exponent. So there are two types that you might come across. This type sides in we try to put both sides of our equation into the same base. What do I mean by that? I'm writing this side. This says base 5 with exponent 10 minus 2x. My base is 5. This side is not written in exponential form. Can we get this into the same base? Can I write this as base 5 as well? I know I want to use base 5 because this side is base 5. Well, let's think. 5 times 5 is 25. 25 times 5 is a 125. If I multiply 5 3 times, I'll get to the 125. So I can rewrite this as 5 to the third. Once you have both sides written in terms of the same base, you can ignore the base and just work with the exponents. The exponent 10 minus 2x has to equal the exponent 3, because if the two bases are the same, their exponents have to be the same as well. And then you just solve this equation, which is not a hard equation. You bring the 10 to the other side. You get negative 2x equals negative 7, and 3 minus 10. Divide both sides by negative 2. And a negative over negative becomes positive. And it turns out your x turns out to be 7/2. You can leave it. You don't have to change it to decimal. You don't have to. You can leave it as an improper fraction, just like that. That's your answer. In order for this to work, this exponent would have had to come out to be 3, and therefore it has to be 7/2. Here's another one like that. I'm going to give you this one to try. 2 to the x plus 4 equals 32. See if you can solve that. I'm giving you a few minutes to try it on your own. We have 2 to the x plus 4 equals 32. This is obviously being written in base 2. Let's see if we can put 32 in base 2 as well. So let's start. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. I actually have to multiply 2 5 times to get 32. So this will give me 2 to the x plus 4 equals 2 to the 5th. And now, since I have the two bases the same, I can set their exponents to each other. X plus 4 has to equal 5. And therefore my x equals 1. So my final answer is x equal to 1. I hope some of you got that answer. Okay, I want to do one more like this, similar. 5, here's the next one. 5 to the 2x exponent is 64. And if I proceed the same way I did this example, I'm going to try and put the 64 in base 5. In other words, let's see, 5 to what exponent will give me 64? Well, if I start at 5, 5 times 5 is 25. Well, that's not big enough. But 25 times 5 gives me 125. And I totally skipped over the 64. I never got to 64 because 64 is not one of the powers of 5. It's not 5 to some exponent. So what happens when we have this situation? So we mentioned what we do is we put the word log next to each of these expressions. So I get log of 2 to the x equals log 64. And notice the log, I didn't even put a base next to it because the base I want to use is base 10. I want to use a common logarithm. And the reason I want to use a common logarithm is because then I could go to my calculator. On my calculator, there is base 10 logs, and there's one other type of logs, and I'm going to talk about that in a minute after we finish this problem. Now, why did I bother to go to the log? Because I know when I have logs, if I have the word log in it, then I know that the exponent can be then transferred to the front and become the coefficient, because Now I'm dealing with log 5, which itself is an exponent. And therefore, when you raise an exponent to another exponent, like we said over here, the exponent simply becomes the coefficient. So therefore, this will become 2x log 5 equals log 64. And the first thing I want to do is get rid of this log 5. And this is, I'm going to do this all on my calculator. I'm going to get 2x equals the log of 64 divided by the log of 5. So here we are, log 64. This is what I'm going to do on my calculator. I'm going to press my log button. And I'm going to put in the 64, close that parentheses, press divide, and press my log button again, because I know my log button on my calculator is common logs. It's based. Then I'm going to put in the 5. Well, let's see what I get when I do that. Log 64, close parentheses, divide by log 5, and I get this equals to 2.584059, etc. if you did on your calculator. And this is what my 2x is equal to, but I don't want 2x, I want to find out what x is, so now I'm going to divide both sides by 2. So I'm going to do divide by 2. And my answer, let's say they want, obviously the answer is not an even answer, it's coming out to a decimal. I get x equal to 1.29. Let's say to 2 decimal places. They will usually tell you to round off either to the nearest hundredth or the nearest tenth. This, if to the nearest hundredth, this is 1.29. To the nearest tenth, it would be 1.3. Again, it doesn't come out evenly because of this number is a long decimal. It's an irrational number. But we can also, we see that we can solve exponential equations, even if we can't put them in the same base, by using logs. Okay. Just one final comment. We really have completed the work for the course. I wanted to mention one other thing when you're looking at your calculator, because this is something that's really going to be very important when you go on to further math, especially pre-calculus and calculus. If you look, usually there's a button that says log, and then right near it, someplace, either on top or a bottom or a side, there's a button that says LN. Now, LN is also a log button. The LOG button we know is the common log button. It's the button whose base is 10. This is log base 10. LN is another log button. The base of that log is a number E. Now, E is a number that's called the natural number. It happens to be an irrational number. In other words, it's a number that has a long, long decimal. It's a non-ending, non-repeating decimal. It's something like 2.1. No, 2.718. And it keeps going on endlessly. Approximately 2.7. but it's an irrational number. So it's a number sort of like the number pi that you've probably seen when you were finding the area of a circle or something. It's an irrational number. So instead of writing down the number, and you're not knowing where to stop, you give it a special name. The name for this number is E. It's called, I don't know why they used E. It's called the natural number because it comes up, it pops up in naturally in certain situations. It's very important in use in calculus, in use in population, exponential growth problems. It comes up. You don't have to know where it comes up and why it comes up. It's just an important number, and therefore that number is also used as the base of logs. So we have these two log buttons. Again, the one that we're most commonly going to use is just the plain common log, the base 10. But again, you will see eventually LNs, and when you see the word LN, all you means is it's a log, and the base being used for that log is the special number E. Something that you might be interested to note, which is really important to note, is that when you have the log of any number, base B, you take the log with any base, and remember your base just has to be a positive number. It could be 10, it could be E, it could be 2, it could be 5, it could be a quarter. It just has to be a positive number. If you take the log of B, where your base is B, your answer has to turn out to be 1. Why? Well, if we'll put it in exponential form, you'll see right away why. B in exponential form, the base would be B. The exponent on the other side is 1. That obviously B to the 1 has to equal B. So when the base matches the number next to the log, the answer has to be 1. In terms of this, log of 10, obviously the base is 10, has to be 1. You could even stick it into your calculator and you'll see. Press your log button, press 10, it'll come out to be 1. ln of E which will mean log base E of E, these two match, has to equal 1. So these are the important things that you may, again, and I don't think you're going to see anything that has to do with ln, but if you do see it, you can realize that all it is a regular log being used. What we're using is a special base, this number E, that has special significance in real life situations. It's used in figuring out population questions, et cetera, and it's programmed into your calculator. Any scientific calculator will have a log button, meaning its base is 10, and an ln button, which means the base is E. I'm going to stop right here. Just a reminder, all your work has to be completed for the course by December 5th. That's the Saturday by, I think I have set it for 8 p.m. That means all the work on Delta Math, all the quizzes on Delta Math, the homeworks on Delta Math, all the work on Blackboard. If you have not done the midterm yet on Blackboard, then you have to contact me so I can reset it. But everything else is open to be done. The only thing that's not doesn't have a deadline by Saturday, is the practice final. Don't forget, try that practice final. It is for your sake to see that you understand and know the type of questions. The practice final has a total of 40 questions, but the actual final will be 30 questions. Your final is next Friday, a week from Friday, from 12 until 2. And remember, once you start the exam, it's going to be on Blackboard the same way that the practice exam is and the same way that the midterm was. Your exam is going to be on Blackboard, and you must sign into Blackboard. If you run into problems, you have to make sure you get in touch with me as soon as possible. Our last class is this Tuesday. Thursday is a study day, and your final is on Friday. Does anybody have any questions they want to ask me? Otherwise, class is over. I'll wait a few minutes if anybody wants to stay and ask questions. You too, have a good weekend. Okay, I'm going to end this for everybody since nobody seems to be having any questions. Have a good weekend. Finish up all your work.